Okay, so now what we're going to do is we're going to do some vector multiplication using matrices. Now, I'm actually going to go through a little bit more than Edgenuity does. We're going to cover four types of transformations. So there's translations where you move left or right or up or down or a combination of. Reflection across the line. So we're going to reflect across the y-axis, x-axis, the line y equals x, and the line y equals negative x. We're going to rotate by degrees counterclockwise, and then we're going to do dilations. Now we're going to cover these in a certain order. So we're going to do translations first, dilations second, reflections third, and rotations last. Okay? All right. So to translate a vector by using a matrix, you're actually going to be using vector addition. So let's say you have a vector or vectors that are described by oops, 1, 1, 1, 4. We're going to put the word shape here too because Edgenuity actually talks about shapes as well. All right, so what you're going to do, let's say you have these 4 points, and if you plot them, you see that they actually make a triangle. Now, what, and by the way, this is called the pre-image. Okay, so now let's say you want to use matrices to help you move these move this pre-image in a certain way. So let's say we want to move our triangle left 5 and down 2. So the first thing we would do is we would write our points as a matrix. The x's make the first column, and the y's, or excuse me, the x's make the first row, and the y's make the second row. Okay? So 1, 1. So that's your first point. 1, 4, 4, 3. Okay? Now we're going to add a matrix. Now, when we add matrices, they have to be the same size. To move left, we're going to do -5. And to move down, we're going to do -2. Now we have to add those to each one of our points. Okay? So once we add those, we get -4, -4, -1, -1, +2, and +1. This will result in our image triangle. So -4, -1, -4, +2, and -1, 1. And if we track each point on the coordinate, we will see that each point actually moved left 5, down 2. Okay, so that's how you do a translation. Okay, now let's talk dilation. Okay, so we're going to do vector or shape. So a dilation is something that makes something bigger or smaller. Okay. And we do this by scalar multiplication. Now, in order to keep things a little simple, we're going to keep our scalars positive. Because when we multiply by a negative scalar, it changes directions and things like that. Okay, so we're going to keep our scalar positive. If k is, the absolute value of k is greater than 0 but less than 1. Okay, which actually I don't need those absolute value bars since I just said everything's positive. I'll write that down. Okay, then that means you're multiplying by a number less than 1, so your object will get smaller. If k is greater than 1, your preimage will result in a larger image. Okay? All right. If you're talking a single vector, your scale factor will affect the magnitude or the length of the vector. Okay, so let's get an xy axis. I like using triangles for this because triangles are actually easier to kind of see. So let's define our triangle by the point 2, 1, 5, 1, 1, 3. And let's say I want to make it bigger by 2. Okay, the scalar we usually call a scale factor. So what you would do is you write down your points, multiply everybody by 2. I'm going to have to make my xy axis a bit bigger. Okay, so we're going to have 4, 2. Oh, let me graph our original. So 2, 1, 5, 1. So there's our original triangle. And then here is our enlargement. Uh-oh, I messed up my original graph. You guys didn't tell me. Okay, here we go. 2, 1, 5, 1. There we go. That's better. There we go. All right, now let's finish that one up. 2. Okay, so that provides us a triangle that's 2 times as large. Okay, now if you remember from last year, if you got to this point in Math 2, or a couple years ago when you were in Math 2, you'll remember something called a center of dilation. Okay, when you do transfer a dilation like this, your center of dilation is from 0, 0. Okay, we're not going to worry about that too much in this class, but you do have a center of dilation at 0, 0. Okay, all right. Okay, let's talk reflections. Okay, we're going to deal with four basic types of reflections. We're going to do an x-axis reflection, a y-axis, a y equals x, and a y equals negative x. Okay, now what you're going to do is these are called your transformation matrices. Okay, so your transformation matrix for your x-axis reflection is 1, 0, 0, negative 1. Okay, your y-axis reflection y equals x, and then okay. So what we're going to do is I'm going to take the same triangle that we had for our dilation, okay, and we're going to multiply each one of our transformation matrices by our original set of points, and we're going to see what happens. Okay, so now you're always going to put the transformation matrix first. Okay, I'm just going to write out the multiplication. Let me put a little bit of a line to kind of separate the work. And we're just going to kind of think about what happens to our coordinates as we do these multiplications. How do the values of x and y change? All right, so what I'm going to do right now is I'm just going to go ahead and multiply these. I'm going to multiply them by hand, so if you want to hit fast forward or 1.5 speed, that's fine, kind of speed me up. Okay, so I'm just going to multiply them. If you want to multiply them with me, that's great. Okay, now I'm not going to write any work here. Okay, and as I'm doing these, ask yourself how the coordinates are changing. How are the coordinates going from the pre-image to the image? How are things changing? How can you describe it? just lost my place. Okay, so what happened? What do you think? Well, for the first one, it looks like the y coordinates changed sign. Okay, this one, it looks like the x coordinates changed sign. Okay, this one, it looks like they traded. Okay, and this last one, it looks like x and y traded and changed signs. Okay, now let's very quickly graph those. Okay. Okay. So I'm going to go ahead and graph the original pre-image for each one. And then I'm going to graph what we call the image. So pre-image, image. Okay. Oops. Get a little bit bigger. Okay, so the pre-image I'll put in blue, and then the image I'll put in red. So let me graph all of my pre-images first. Okay, so there are all my pre-images. Okay, there's my x-axis reflection, so it flipped upside down. Okay. Here's my y-axis reflection. So you can see it flipped kind of side to side. Okay, now the diagonal lines here are a little bit weird. Take a little bit of practice. Okay, here we go. So 1, 2, 1, 5, and then 3, 1. Zoom in a little bit. Okay, ooh, that's a net. Let's try that again. Whoa, hello. Okay, let's zoom in on that. So, oops. Okay, so they switch. So 2, 1 switches to 1, 2. 3, 1 switches to, or 1, 3 switches to 3, 1. And then 5, 1 switches to 1, 5. Okay. Now, it's truly better to do this like on a piece of paper with a ruler, but if I graph the line y equals x, okay. So if you measure the distance from each point to the line of reflection, you'll see that they're equidistant. So equal distance, equal distance, equal distance, equal distance. Okay? All right, little hard to see, especially on OneNote. It's easier actually on a piece of paper. Okay? All right, so now let's do the, this is the one that I find the hardest. Okay, so -1, -2. Oop, let me use red. Okay, -1, -5, -3, and that should be a -1. Okay, so let's kind of make it bigger so you can see. Okay, so my line of reflection is right here. Okay, and again, here, let's get the ruler out. If I measure pre-image point to image point, you'll see that they're equidistant from each other because it is a reflection. And you should create, when you measure, you should create a 90-degree angle. Whoopsie. And see how the ruler is like at 45 degrees? Okay. All right. So that is how you do reflections. Okay. You can also reflect single vectors, but that's what that looks like. Okay, so we're going to go ahead and do rotations in a second video, just to kind of keep the video shorter. Okay, and we will handle rotations in our next video. All right, see you later.